Actually, I want to show you something. No, this chapter is not rocket science. However, it holds the key to solving a lot of problems in engineering, technology, and even economics. In fact, anything. If you are able to solve differential equations, especially the very complex ones, you can actually solve a lot of the world problems. Okay, so now let's get a little bit into D first. What is a differential equation? It is simply what's a differential equation? It is simply an equation. Okay, let me erase this one first. I mean, this one's can be quite disruptive. Okay, a differential equation is simply an equation that contains, say, dy dx or d2y dx square or the higher derivative. Any equation that contains any of these derivatives or combination of them, they are called DEs. And the thing is, many physical phenomena, right? Many physical phenomena, they are actually governed by DEs. No? As physics students, you already know the falling object. You already know the parachute. You also know about the spring, which behave like a harmonic motion. This is called the simple harmonic motion. A lot of these things that you see here, they are actually governed by DEs. In a minute. And what happened is, from these DEs that you have for each of them, in a way you are modeling these real life scenarios using a math model which is called a DE. And then if you know how to solve differential equations, right, you actually hold the key to predict the future. No? That powerful. No? Like for example, if you can understand how a hot boiling water cools down and how it is governed by, what's the law that you use for the cooling down of hot water? It's called the Newton's law of cooling. So you have studied the thing very well. You could actually predict how the temperature will fluctuate over the next couple of minutes. No? It's true. If you are able to capture all the parameters in the whole world, all things that affect what's going to happen, and can put them into a DE, and then you got a huge computer that can help you to solve this very complex DE. The truth is, you will know exactly what's going to happen tomorrow. You will know that the stock price of the SIA will go up or go down. Down. It went up or went down? Oh, it goes down. You tried. The stock says that your prediction says it goes down. Or you have a way to predict the condition or weather in the next few hours exactly. Not always the weather forecast that we have in Singapore always will soon, They say it rains, doesn't rain. It say it doesn't rain, it rains, because that means they didn't solve the DE correctly, or they haven't captured the information rightly to form the correct DE. So if you actually study DE to the very high level, you can actually really solve a lot of world problems. No? You know exactly when the missile will land at your doorstep. You know what I mean? Right? Missile. Okay. Now, so our job here is we now have understood what D is, and the good thing is the simplest form of DE, such as this, is all too familiar to you. Let's say, Mr. Lim, haven't I done this before? Yes, you have done this before. Not just once, you have done it many times over. Right? And on those occasions, we just call them an integration problem. Technically, this same integration problem that you were doing and you are very familiar now, this equation technically is also called a differential equation. Aidan, why do you think this is called a differential equation? Wow, Aiden, you're a good learner, no? You heard what I say, right? It's simply because it contains the dy dx. And all these equations that you see right in front here, they are called differential equation. And our job in this chapter is to learn how to solve dE. Now, in our module, right, it is only one chapter out of 4 chapters, so dE is only one chapter. In the university, right, I spent 6 months on what is called ordinary differential equation. 6 months. And then another 6 months on another set of differential equation. Differential equation which are not ordinary, what they call? PD. Yeah, it's called partial, it's not extraordinary, no.
PD.
It's called PD, partial. So this dE that is seen here is called ordinary differential equation. And just tell ahead of time, to solve a dE means to get from this step, and I know what's going to happen, or we're going to leave this room soon, say, you have learned this already. You can say, Mr. Lim, this chapter is like old story. It's true, the starting part is old story. Like, if you can get from the blue box to the blue writing, you're deemed to have solved the dE.
Yes.
Woo. And you feel good because you're not learning anything new. It is the same old story. Mathematically, in math books, they always describe this way, They use the word implicit relationship and explicit relationship. Ups. Explicit. So they like to describe this way, They say, in a dE, right, just imagine you're not that clever, you do not know how to solve a dE, you just saw that this is a dE, dy dx equals to cosine x is a dE. Supposedly, you haven't learned how to solve this by the virtue of the fact that the y and x variable sit together in an equation like this. There is an implied relationship between y and x. So a dE actually offers you an implied relationship between the y and x. And upon solving it, you are getting so-called the explicit relationship, which means the clear relationship between y and x. So solving a dE, textbook will describe for you this way, It is getting from the implied relationship form into the explicit form. In case you think that, wow, that's it, I know everything about dE. It's not, no. dE can get very complicated very quickly. So this is just the start, okay? The preamble to make you happy first. As you go down the pages, dE becomes harder and harder. How is that so? You will see. And the way to learn dE is like this, to learn dE is, first and foremost, you have to learn how differential equations are classified. So the first thing that people will learn when they learn dE, how dEs are classified. dE are classified based on basically 2 things. One is called the order, and one is called the degree. Right? So dEs are classified based on 2 things. Okay, so if you're wondering why bother to learn about the classification at the start, it is because the way to go about learning dE is like this, you must recognize that, this is dE ABC. I'm going to use method ABC for this dE to solve. This is dE XYZ. I'm going to use the method for XYZ to solve the dE. So that's how dE is done, It's just like seeing a doctor. The doctor see you coughing this way, they will give you the cough syrup for this kind of cough. If you cough this other way with phlegm, right? Then they give you another kind of cough syrup. You know what I mean? It's like that, It's just like medicine. Just like if you are a doctor, So dE works this way. You want to understand how it is classified, and if I could, you have a book of all the different classification of dE, and along with each of these pages, you have the solution for that kind of dE. Lo and behold, the dE that you saw just now is typically termed as dE solvable by, okay, let's see, these are 2 words. Let's see who can guess the 2 words.
Direct integration.
Wow! Is dE solvable by direct integration. So they classify this D like that, Let me show you another one. If you have a D that look like this, let me call an example here to impress upon you how important it is to know how to, just with a slight twist. Okay. It looks the same, but it's not to be solved the way you are thinking. Okay, this D is given another name, Okay, Mahir, do you happen to know? Anybody?
Non-linear.
Anybody happen to know the name of such a D? It is called variable separable DE. Down the pages you will see it, but just that I'm giving you a heads up that
Is that solution why you use
potentially. So when you recognize that this is DE solvable by direct integration, you use that method to solve. Then see, this is an account of DE, I therefore use the known method for this DE. But to enable yourself to do this, right, you must first and foremost learn how things are classified in DEs. What are the two words? Let's hear from Chen Yin. In classification of DE, what are the two buzzwords? What are the two words that we use to classify DEs? One is start with O, which is order, the other start with D. Yeah. Okay, let's understand these two terms. Okay. Okay. Here in example 1, right, it wants you to actually label the D's. So like this one again. In example 1, part 1 again. This DE that you see in part 1, okay, you want to first and foremost understand whether or not it is so-called linear or non-linear first. To be a linear DE, right, it must be expressible in this form. Okay, this is in the form of a summation. If you write down the summation a little bit more, right? Okay, so let me say there's actually a third factor: order, degree, linear or non-linear. So there are three classification, three characteristics to classify. Okay, the order, the degree, and then whether it's linear or not. So if you have a DE that look like this, okay, like this, it is deemed to be a linear DE. So let's look at the first one. Do you think this is linear, part 1? Based on the definition? Yes, so the part 1 is actually a linear. Okay. How do you determine the order of a DE? The order of DE is dependent on the highest derivative in the equation. Like in this equation, right? In this equation, what is the highest order of the derivative in this equation? The highest order of derivative in this equation is actually 1, right? So this one is actually order 1. Order is 1. Right? Then next thing is the degree. The degree represents the degree of the highest derivative. In this equation, this is the highest derivative, and the degree of this derivative is actually power 1. Okay, power 1. Therefore, the degree in this case is equals to 1. Okay. Let's look at the second. So for this one, right? For this one order is 1 and degree is 1 for the part 1. Okay. Let's talk about part 2. Okay. Part 2. Is part 2 a linear DE? Okay, to be a linear DE, right, all the y, all the dy dx, all the d2y dx squared and so on, all must have degree 1, You look carefully. you look at this expression again. None of them can be raised to powers. So like in the second example, right? Y is power 1. Dy dx is also power 1. So therefore, in part 2, it is again deemed to be linear. Okay, how do you determine the order of this dE? Order d. To determine the order of dE, right, you look at the highest derivative in the equation. The highest derivative in the equation is just dy dx. Dy dx is the first derivative, right? So therefore, this is going to be 1. And the degree, right? The degree depends on the degree of the highest derivative. And this again is, okay. I hope you can see. Alright, so now that we have seen 2 examples of first of linear differential equation, the order is 1, the degree is 1. Let's look at part 3. Let's hear from, okay, after Chen Yan has been cane, isn't it? They work in pairs. Okay, cane, part 3. Do you think it's linear or not? No, it's non-linear, right? Non-linear. Non-linear. How about the order? Okay, order depends on the derivative, right? Yeah, right. The order is 3. How about the degree? Right, because the highest derivative is the third derivative, and the third derivative has a degree of 2, so it's 2. Simple. And then now we go into the fourth one. Okay, in case you're not sure about this notation, this simply means d2y over dx square plus dy dx square minus 2y equals to sine x. Okay, after k, it has to be cube. Right, cube isn't it? It's cube, isn't it? Yeah, cube, sorry. Okay, then it must be Jingwen's turn, right? Jingwen, to start off with, is this linear? No, right? Because there's a boundary to the dy dx. So it's non-linear. Okay, let's write non-linear. It's non-linear. How about the order? Order is 2 based on the second derivative. So order is 2. And how about the degree? The degree depends on the degree of the right. So therefore degree is 1. It's a trick question, you know. Okay. It's a trick question. So degree is 1. That's how you actually classify these. Right? Linear or non-linear, and then after that the order, and after that the degree. Caitlin, say? Because degree depends on the degree of the highest derivative. It's like that. The highest derivative has a degree of 1. That's a degree 1. Right. Okay. So now we are ready to look at more DEs. Okay. At this point in time, you won't know how to get a solution to this DE. You don't know. Most of you will know, right? This is a DE. To solve this DE is not as trivial as you think. You know, it's not. But in this question, they are telling that the solution to this DE look like this. In my learning experience again in DE, right, I was quite a bit amused that in the solution of DE, right, many times people start off by trying out to get the solution first, not solving it the conventional way. They just guess the answer first. Then they try, doesn't work. Then they twist a bit, try, twist it. Got such thing that is done in DE, let me say, just try. Because sometimes D are not easy to solve. So when things are not easy to solve, it might be worth the while to just so-called tikam a bit, and then you try. It doesn't work, it tweaks a bit. So in math, even though I say trial and error in math, right? You must remember, no, trial and error in math, it's not like trial and error you do in anything like games or your any daily life thing. No. Trial and error in math means to try and error intelligently, no? Not blindly only, right? Okay. So in this particular case, you do not know how to solve the D. Someone comes along and say, hey guys, this is believed to be the solution of the DE. Could you verify that what I claim is true? Let's hear from Zoe. So Zoe, someone comes along and tells you, say, hey, this is a DE, haha, we can't solve. But I'm telling you, no, there's a solution to this DE. I know you can't solve, but can you at least verify that what I say is true? What would you do to verify? And then Zoe say, not to worry, you start from left hand side. Like all good math people, we always start from left hand side. And you say left hand side contains what? Y. Sorry, what do you have on left? Oh, sorry, left hand side is dy dx. Sorry, dy dx plus y, right? The left hand side of the intended DE is this. So what Zoe going to do is, she's going to plug in dy dx. Where do you get the dy dx to plug in? Okay, Zoe, say, what are you going to replace dy dx for? Yep. And what do you hope that this whole thing will tidy up to? If you were to actually do your arithmetic, you will realize that eventually, what would you get? You get x squared minus nothing, just x squared. And this equals to and we are done. So to verify that something is a solution of the DE, you simply do like what you would do in the good old days. The same concept, just that now this verification involves differentiation, that's all. But the concept is the same, because in the past, in the lower years, if you're asked to verify that something is a solution to an equation, you simply put that thing in the left hand side and ensure that it works out to the right hand side. So same thing, right? Okay, I'm going to ask this question, although it's not asked in this question itself. Let me ask you again. Back to Zoe again. Do you think that this is the only solution to this DE? What do you think? You have any? Are you able to deduce another solution? Okay. So the question is, if this is a solution to the DE, is it possible to have more than one solution to the same DE? Potentially it is possible. No, potentially it's possible. Potentially. Okay. We'll see again. We'll see. Because you see, when you solve an integration problem like this, okay, for some simple question like this, right? You already know that such an equation, right, can potentially have many possible solutions, though, like x squared plus 1, x squared minus half, and so on, right now. Right now. So these are possible solutions to the same so-called DE, and to write an expression that covers all of them, we will potentially write like this. And I want you to know ahead of time that such a solution to this DE is called a general solution. Now, what do you call the individual solutions such as this? Where the C in the first one is 1, where the C in the second instance is -1. I want you to know ahead of time that such individual solutions, they are termed so each of them is a particular solution of the DE. Simple. So what I'm trying to impress on you is that first, given the DE, you now know how to verify that a solution is a solution to a DE, right? And now you also understood there's a notion of what's called a general solution versus particular solutions. And it's here. Right here. So it asks you to verify that every member of this function y equals x squared plus c is a solution to this. Okay, don't have to do it, just do it in your mind. How would you verify? You verify by starting with the left hand side, which is dy dx, and then you work out the dy dx, which is indeed 2x, and it's equals to the right hand side. So by the simple calculation that the left hand side, which is dy dx, is equals to the differentiation of the suspected solution, and upon differentiating this, you find that it is equals to the right hand side. So you have successfully established or verified that indeed it is a solution to that DE. Then part 2, right? Part 2, it says y equals 2 when x is, so if your y is x squared plus x, y is x squared plus c, if y is 2 when x is 1, y is 2 when x is 1, that allows you to obtain a specific value for c, and that specific value for c turns out to be 1. So therefore, you get a solution that looks like this. Such a solution that you see here, what's the name of such a solution? Let's hear from, but here what? Particular solution. Okay, let me pause for a moment and say this thing. In the chapter of DE, right, the starting is quite like bookwork, you know. You have to learn all the different terms. Okay, what are the terms you have encountered so far? We have encountered the term differential equation. In your head, what are differential equation? Let's hear from Green. What? That contains dy dx. Okay, so you also learn that DE are classified. Green, let's see how far I can go without looking at the book. You have learned that DE can be classified based on linear or non-linear? The order, the degree. Okay, then we have also learned from the first example how we can verify that something is a solution to a DE. How do you do it? Just sub it in. And then we have learned two terms towards the end of our discussion. If I ask you to describe the difference between the two of them, what would you say?
General is constant, and particular is become.
Yeah, so he's right. General solution is where the constant is just the unknown c. And given a condition such as y equals to 2 when x is 1, you are able to calculate a specific value for c, then such a solution is called a particular solution. Okay. Then there's something you want to learn, that's called family of, you have already agreed with me that for this equation, the general solution looks like this. By solving the DE, right? By solving the DE, we get x squared plus c. And now if I say, give c different values. By giving c different values, you can actually find that you can sketch different graphs using that solution x squared plus c by giving c different values. Maybe this c equals to 0, c equals to minus 2, and c equals to 3. If you repeat the process by giving c many other different values and drawing them on the same x and y plane, what would you get? You will get what?
What?
If you were to draw the solution curves for many other different values of c, tell me what would you get on the xy plane? You will get your batik design. Your batik, batik shirt, those like, batik shirt got a lot of nice.
You just get the entire field area.
You get an entire field area. You just get a
No,
paper.
you're again put in discrete values. You don't put in continuous values. That means you put in staccato values. Staccato values. If you put legato values, you'll get like what you say lah. By putting staccato values, you get a batik shirt.
What is that music? What's the music?
Yeah, you understand what I mean, right? And that's how people produce nice computer graphics, by actually you're plotting the different solution for the same curve. And these curves are very beautiful, you know why? They won't overlap,
I will be concerned if
Yeah, they won't overlap.
I will be concerned if you do.
Yeah. And then they form very nice patterns, so you can produce your batik design. In my young days, we do batik design by using a potato. We cut the potato, then then chop, then produce a kind of a batik shirt. It's quite not so nice because you use hand to do things, right? The thing is never perfect. Some people
wax.
Wax,
Wax to do batik.
Some people are actually looking out for things that's handmade, and they think that that imperfection is actually a very nice thing. But I suspect for people who are math and science, you want everything to be sweet, perfect, There's a building downtown next to Funan Center, a grey color building. Do you ever notice it?
What?
If you go to Funan Center, there's a building next to it, it's grey color.
Okay.
That building is called the Treasury. Yours sincerely was once upon a time.
You used to imagine it before.
Not just I worked there, I was actually the building manager. Apart from doing government's budget, I was tasked to also take care of the building. Why is that so low? Because in the office very funny, all ladies, I was about the only man of that grade, They say because I'm the only man of grade, can I also take charge of the building? So I took care of the building. That building, you look carefully on the facade, right? You look at the tiles carefully, it's not homogeneous, In my opinion, it's patchwork. Because the granite that was cut, they happen to cut from different part of the mountain, somewhere overseas European country, And because they come from different part of the mountain, the granite pasted on the wall, the cladding, don't look nice, But some people say it's nice, although it's not homogeneous because it's natural. They feel that's just nice. I just want to know how do you feel? Do you like things that's very homogeneous and nice, homogeneous tiles on the floor, or you don't mind your tiles that are different patch? I'm just curious. To buy a handmade shoes, it's much more expensive, and may not as durable, Machine-made shoes are actually more durable, but sometimes some people just like handmade products, Okay, anyway, back to batik. Okay, anyway, you solve this, and you paint all these graphs on the same diagram, you get a nice computer graphic. Okay. So now the notion of general solution is reiterated here, and then the different solution that you obtain, the different particular solution that you obtain from here, when you draw them together, they form a family of solution curves. So this term, family of solution curve, used in this context, basically means the different particular solution that you can obtain from the same general solution, and together, collectively, they are called the family of solution curves. Okay, there's this notion called initial value problem. Okay, depending on what is initial to you, to some people initial means when x is 0, to some people initial means when x is 1, or to some problem initial value could be x plus 2. Maybe the bomb only start 2 seconds later. So as long as they're given some conditions, okay, and then that condition allows you to work out a specific value for the C, then by putting the value of C inside the general solution, you get what is called the particular solution. And you may think that why am I spending time talking about the classification, telling stories like this? It's because if you don't get this part of the D correct, down the stream you get a bit lost, So now at least I hope by now you know that actually there's classification of D, and in your mind you know that you're going to learn with anticipation. You know down the pages we are going to discuss DA, the solution method for DA, and DB, and D, and then we know about particular solution versus general solution, and the notion of family or solution curves. Full stop. We deserve a short break, and after we continue with the first type. Okay, we deserve a short break. You can go walk around, jump around, run around the room, go toilet.
This chapter is confused.
Really? Are you confused?
Yes.
Now you're confused. Which part are you confused?
No.
Shall we? Okay. It is called separable equations. Some books call it variable separable. Some books just call it separable. So what is a separable equation? As the name suggests, if I give an equation that's like this, it basically means I can separate them into two parts. All those that involve the y to the left, and all those involving x to the right. So this is what we meant. Can you see? Here. Like that. The term variable separable is to describe to you. Okay, the thing I drew not very accurate. Should be from here. Yeah. Okay. But it's the same idea. The same idea. Whether or not you start off with the dy dx equals fx or hy, or this other one. Okay, let's say, how do we separate the variables? We can separate variables by so if I ask you what is a separable equation, it is simply an equation where the y's can be separated from the x's. One more caution, I want you to realize that the JCs, those who do pure math, they won't allow people to write this way. Personally, I also don't. I also don't do this. I will never write an expression where the dy or the dx is standalone. I started this place and I saw this done in the notes, and later on I found that actually textbooks that is used also do that. So after a long time, what did I do? You can't beat them. What do you do? You join them. So I'm saying, okay, never mind. But I want you to know that actually JC students don't do that. Okay?
It makes conceptually easier.
Yeah.
The concept behind dy dx is just change in y will change in x.
No.
Change in comes
The reason is because this expression itself is undefined. By itself has no meaning. Dx by itself has no meaning. I want to caution you. It is not the case of
delta x delta y.
if it's delta x and delta y is okay, but dx and dy by themselves, they have no meaning on. So people who do pure math, they won't do like this. Okay, I'm not going to fight with people over this. I'm going to tell you that AP calculus allows it. So let's do it again. So the way to do it is,
No, how else do we write it if you don't write it like this?
okay, so what people would do is, for example, for the same expression, let me show you how people do it, say carefully and properly. They say you must put hy first, then got dy dx, then equals to f of x. Then the proper way is, from here, now we actually integrate with respect to x on both sides. By integrating with respect to x on the left side, chain rule allows me to change this to dy. So the presentation that is needed to do it carefully and properly is like this. Doesn't matter, no. So do not be too uptight about it. I'm okay. The school here also is okay. My colleagues here are also okay. We have accustomed to it. Even the textbook that is the de facto standard for all high school calculus students, right? The book called Calculus by, what's the author's name? You know, Howard Anton. There's a very good book, no? Called Calculus by Howard Anton. This book is the de facto book that you must read if you claim to be a calculus student. You know? Will you buy and read it? I remember buying it for $30. My time, $30. I still have the book at home. Yeah. Okay, in any case, that book also does it. So to do a variable separable equation, basically we are trying to separate them into two sides and then after that performing the integration. Interestingly, while I do not embrace the red color, I personally I'm okay with this. No, if you jump straight to this line, let me say, if you do that so-called illegal step, but you don't stop there, you immediately put the integral sign, I'm more receptive to it. You know what I mean? You don't stop there. It means you don't stop here. You right away.
On the 1000.
Actually, not bad. Not too bad. Not too bad. Okay. To give you an example. For example, if you have, say, if you have dy dx equals to, for example, right, x square y, for example, right? If on the next line you write like that, on the next line you write like this, but you do not stop there, you immediately plonk in this fella, actually I am more receptive, you know. Yeah, because technically it's not wrong. I will just assume that you did it the right way. I'm more comfortable that way, like I can solve it better.
Found the 1314 pages.
Okay, Zoe, are you confused? Okay, so to make the confusion less confusing, just do an example. Okay, let's do a first example.
Yeah, about example, by the way.
That's okay, sir.
Okay, trust me, I don't say a single word. This one classic example where a picture tells 1,000 words. By looking at this first example, the notion of separable equation becomes crystal clear. The word separable means, I want to caution you at this juncture that there are occasions where the equation looks very much like separable, but it's not, you know. This blue color is not. Separable in terms of the fact that it is a function of x times a function of y. so they can bring it over as a denominator kind of thing. No? It's not separable the way you think, right? Okay, so anyway, this blue color is not separable. This is not a separable equation, right? So by looking at the first work example, you have conquered the first type of DE. Let's make a guess again. In the AP Calculus syllabus, how many type of DE are you required to learn?
How many types of DE are there?
The actual AP Calculus. The truth is, this is the only type. Just now we talked about the first type where Mahil immediately say is solvable by direct integration. If you look at carefully, the one that's solvable by direct integration, this type, right, technically is also separable. Like for example, you can imagine that this is times 1, is it? And the 1 represents a function of y. So therefore, solvable by direct integration is actually a subset of separable. And the interesting thing is, AP Calculus exam only, or AB only tests you on this one type. Yeah. However, as the NUS High School of Math and Science, we won't stop there. We want to actually scale high mountains. We want to be the A-level plus or the AP plus. We will learn a bit more. The bit more that we learn in this chapter actually spills into the BC syllabus. And then, if we stretch ourselves a bit more towards the end of the chapter, we will cover a bit of what people do in further math. That's provided we have time. I am more inclined to just kill it. Just to kill it, the later part. Okay, so you have to be mentally prepared that in this chapter, we are trying to do more. Okay? So with the first, for example, you have already backed in. You will agree with me that that you know how to solve the DE. You see, the integration is the same as what we did before, no? And in this case, right, you're given a condition. Do you understand how to read this statement? This means when x is 0, y is 2. Using this, you can find the value of c, and with the value of c, the solution that you get is called a particular solution. Very high sounding name, but actually something small. Branding is like, the harder the name to pronounce, the better it is. For example, Ferragamo, Salvatore Ferragamo. I think I hope I pronounced it correctly. Have you heard of this branding? Salvatore Ferragamo. Who has heard of this branding before? Salvatore Ferragamo. Yeah, she has. So she's more atas. If you go to the Orchard, this Ngee City, everybody know LV, Louis Vuitton. Everybody knows. Even auntie also knows. Seriously. But Salvatore Ferragamo, not many people know. Balenciaga, you heard of before? Because some people buy t-shirt with the word there. Some people don't know that that is actually a brand name of a very branded product. Some people say that I pronounce this thing wrongly. Hermes. The Hermes. You don't heard this brand name? Hermes. Yeah. These are the more high sounding and the harder to pronounce, the more atas it is, no? But in math, not like that. Like particular solution, very high sounding. Actually, very small thing. It means the C is known. General solution sounds very big, but actually means the C is unknown, that's all. Okay. Pressing on, we will have example for us to try. Why don't you try and convince me that you have conquered this chapter?
Oh, ATAS abbreviation.
ATAS?
It's not abbreviation, but it's a slang.
It's a slang.
I didn't know it was a slang.
It's a slang.
How
Okay.
I know what the actual meaning is. ATAS is up.
Okay, class,
Atas is just up.
can you do yourself this great favor
The word atas itself means up.
and you try to solve this DE without my intervention to prove to yourself that you have conquered the world? Do you believe me that I can catch anybody here to do it? You can do it without problem. Do you believe me? You try, everybody try. Don't shake your head, no. You're being you gotta nod your head, in agreement. Try, everybody try this. It is variable separable. Even though you haven't had your notes here, you can always take out a piece of paper like Kurdish. Do you have your notes here? No?
Using the online one.
Oh, your online version. Okay, clever. I sent out a soft copy. I'm hoping that I can go digital.
List of numbers that can be used as the input.
Wow, very accurate way of describing it, Yes, domain is actually the set of values that is used as input into the function. It's true.
They can come out with a valid output. You can technically put 0 into y equals to 1 over x. You can technically put that in, but you don't get a valid output. That's my point. What dude?
Okay, I am very sure all of you can do this question without any problem. The first thing is, it is variable separable, and as variable separable equation, you want to separate them into y's on the left versus the x's on the right. And I told just now, I feel more at ease if you can quickly put in the integration sign, to camouflage the uneasiness about a standalone dx or a dy. And once you have separated them into the y's on the left and the x's on the right, what do you do next? You do the obvious, which is
Nothing.
integrate lah. Right, integrate. And lo and behold, I declare to you that this is some people are troubled now. When I say this is a solution, they say, Mr. Lim, can we make y the subject, please? Sometimes can, sometimes very hard. And if it's too hard, don't bother.
You might as well do.
Yep.
Because
Telling the typical students will ask that it's good. Because now you ask, now you know it can. Yeah.
Because it's technically an equation, what?
It's a solution. Because you see, remember I told you, solving a DE means you establish an explicit relationship between x and y. And this is an explicit relationship, a direct relationship between x and y. So is there anyone here who is stuck? Some people did ask me, shouldn't I have a constant on the left and technically yes, but the C1 will take a trip across the river and meet C2 and they hold hands to become a single C.
Technically, yeah, there is a C, but effectively the entire thing only has one constant.
So the 2C will be combined together to become a single. Yes. 不用。You understand? Okay. Don't have to. If you don't want to, it's okay. I know that in lower years it was overly stressed. Where C is an arbitrary constant, Yeah.
So there are people coming to school.
I'm coming down tomorrow. I'm going to school tomorrow. Believe me, in the next question.
Where's the people coming from?
No, just check your email. Apparently people from Cambridge, Imperial and UCL are coming to school on the next 3 days. Apparently.
Do you believe me that in the next question, almost all of you will not get a complete solution? Let's see. Let's try first. I made this remark, okay? I'm saying that almost all of you will not get the complete solution to part 2. Do you believe me? The complete solution.
Tell me what do I like.
Okay, I'm not. Kenneth,
What do I like?
this is not a complete solution.
What do I like? I'm not asking. I know it's not complete. What do
I'll
I
tell you
like?
later. In the meantime, while you do it, let me check the scholarship for you. Hey, by the way, another job you want to try to is to study civil engineering. Civil engineering is not bad, you know. Civil engineering. The builders. You can actually become a civil engineer. Do you know that in a building, only two kind of professionals can become the so-called
Building manager.
not building, project manager of a building. That means under construction. What do you call that? There's term name. That means the top man, the top technical person for the whole building. Only two kind of professionals. One of them obviously is the architect. The other one is actually the civil engineer. No? Yeah, these two persons can be the so-called the main project manager or main project, what do you call it, leader, okay? Yeah. If you are a civil engineer, you could actually think of building a very beautiful bridge. You know, bridges in the world can be very nice, especially those hanging bridges. It's very nice, no? If you've been to some of the big countries, say for example, China, the hanging bridges are quite beautiful, you know? Really, really nice. I haven't been to, say, okay, not yet. Not bad, you're getting there. This guy's clever.
So I still one answer short.
Okay, so you can try to become a civil engineer. Not bad, or architect. Would you consider, no, you'll be a competing person. Okay, let's back to this question.
What do I like?
Case 1. Class, you do a case 1, you know. Case 1.
You're looking at mine, you won't get anything.
Y equals to 0 for all x.
Why is C outside?
Is this a possible solution to this DE? Do you think so?
Yeah.
Imagine if y equals 0 for all x, right?
Yeah, sure. Yeah.
Then the left hand side when differentiated will be dy dx, which is 0. The right hand side when putting y as 0, you also get 0. Case 2. For y not equals to 0,
Okay. No, it doesn't work here.
then you can do it like this. Only when y is not 0, then can you do like that, you know. Because if you were to just integrate without regarding the possibility that y can be 0, your whole integration can just fall apart, you know. And upon solving this equation, you will get this line. Now, in the ensuing arithmetic, I want you to learn that we won't stop here. We will tidy up further. And this tidying up, you want to be accustomed to it because we use it very often.
Let me just eat the ball one.
Okay, don't blink your eyes. Don't blink your eyes. Okay, let's see. Zoe, you're discussing with Jingwen. Tell me, what is the next line?
I think you get plus minus or.
Say. You want to get used to this way of going about the arithmetic, no?
Is A just a constant?
Yeah, where A is an arbitrary constant. Class, I showed you once, when you come across similar arithmetic, you want to be able to go all the way through to the finishing line. You want to lump the plus minus e to the c as a.
Can I write C still?
See me? What is it?
Can I see what C?
There is no condition given to us. Oh, just leave it as C, is it? Yeah. Instead of A, write as C, is it? So your C will be different from the C we had earlier.
Yeah.
Right. So are you happy about these? And understand that you have other lessons after mine, is it? Tuesday, right? Okay. So I think I should stop here to give you some time to go and